Hello, students. As we reach the mid-year point in our Introduction to Linux course, I wanted to go over some material from this first half and make sure that we hit the high points and that you're on track in preparation for the midterm examination. To that end, I will share my screen and we'll begin talking a little bit about the history and philosophy of Linux. That was way back in the beginning of our studies. And you'll recall that Linux is an open source operating system that was highly based upon AT&T's Unix operating system. There are different distributions or distros of Linux, the three major being Fedora, SUSE, and Debian. The package that we are using, Linux Mint, is a derivation of Ubuntu, which is in the Debian line as far as distribution families go. And you can refer to the image on your screen to see how things relate to one another. You'll see Linux Mint over near the bottom left in the hierarchy. Linus Torvalds, a student back in the 90s, was working on a software project as part of his computer science education, and he wrote his own operating system kernel. That same kernel, with advancements and additions, is still the heart of Linux today. We also discussed the GPL, or the GNU public license, and GPL version 2 is the most popular issuance of that license. That is the end user license agreement under which many open source software products are licensed. And you can see on your screen now a little bit about the evolution of Linux up through today, or nearly today. And recall that web servers in the modern marketplace rely really heavily on Linux. Over 60% of the web servers powering the retail and other marketable URLs on the World Wide Web are powered by Linux. A derivation of Linux for handheld devices is Android, and that still powers the majority of smartphones today. Linux.com is a good reference point. It is a site that is hosted by the Linux Foundation, provides lots of useful information on the developments in that realm. Recall that a distro or distribution is a lot more than just the kernel. The kernel is that center or minimum functionality. And when you load a Linux distribution on your computer or inside of a virtual machine, you are really adding a lot more than just that kernel. You are getting proprietary applications, possibly. You're getting a lot of open source tools, a shell. The most popular shell is the Bash shell, and that is what we are using with our Linux Mint virtual machines. You will also be getting a package manager. The package manager that we have under Linux Mint is apt, APT, and you may recall from one of your early assignments that you used apt-get, apt-get, and install to put new applications on your Linux Mint operating system. You have the entire manual page system that is included as part of the distribution. And the GUI tools come along with Linux Mint as well. You have the LibreOffice suite that includes Write and Analog for the Microsoft Word application, as well as a spreadsheet tool and a slide deck organizer or a PowerPoint alike. Also early in the curriculum, there was a discussion of how both operating system software and software in general is delivered to the marketplace. So there are two types of terminology that I want you to keep in mind. That's the release cycle and the maintenance cycle. Now, the release cycle is what it sounds like. It's a set schedule for when new features are bundled together and released to the marketplace. So for instance, we now, most of us are using Linux Mint 19.3 Trisha. Prior to that, there was a 18 dot and a 17 dot, etc. Release of the operating system. At some point in time, older releases are no longer supported. And this is defined by what we call the maintenance cycle. So the maintenance cycle is that length of time for which a particular piece of software is maintained or supported. Let's move our attention to the Linux software realm, where the materials broke the types of software for Linux down into basically three categories. We had the desktop software, server software, and then a category called utilities. So the desktop software is mostly what the end user is familiar with. And you can see on the screen now, we have familiar applications like word processing, like spreadsheets, like our web browser. We might also see video or audio player applications. Here's some examples. There's something called Audacious for Linux distributions, and Rhythmbox. For those that are more audiophiles and interested in perhaps editing or more professional production, there is a tool or editor called Audacity. There are many others as well. As we talk more about the system administrator interface with Linux, we get into talking about server software. And in the server software category, there are lots of interesting subcategories. We've got all of our different web servers. Apache is probably the most recognizable, but there is also something called Nginx. That happens to be a engine that powers some of our familiar websites like Airbnb and Netflix and Hulu and Pinterest as well. Others web server software exists on the marketplace as well. File sharing is an important utility, and Samba, NFS, Network File Share, and Netatalk are three of the most popular either file sharing or serving server applications in existence. Databases are really the power behind most web sites. Anything that is in transactional in nature is going to have the data stored in some organized repository, and that is likely a relational database. MySQL is one of these most popular open source database tools, and in the Linux administration class, we use a little bit and at least familiarize you with MySQL. There are others as well. I point your attention to SQLite. It is what's called an embedded SQL engine. That means its footprint is very small, and it may well be the engine in more Internet of Things appliances because of that small footprint. We've got mail serving. That's an important tool that we all use in today's online world. SendMail, Postfix, GroupWise are just some of the mail serving software that is available in the Linux and Unix realm. But we are moving more and more toward cloud-based services like Yahoo and Gmail for our mail delivery. Blogs are an important topic, and blog servers are aplenty in the Linux world. The most popular is probably WordPress, but you can see there are a few others mentioned here as well. And let's conclude this part of our discussion by talking about the third category of software in the Linux realm, and that is utilities. And really, as a either user or system administrator of Linux, we could not survive without the utilities. That includes the package management, how we load and manage software on our system. And the Debian family uses something called RPM, of which the APT tool is akin to, and Red Hat line in the family uses a tool called Yum. Okay. That's mentioned in your reading materials. Editors that we will soon become very familiar with include Nano, VI, and an offshoot of VI called Vim. Programmers typically gravitate toward Emacs, although it is a much more complicated editor, and we will not discuss that in any detail beyond a mention in this class. Programming languages are in the category of utilities. And although we will not be learning programming in this course, it is important to understand the distinction between the types of programming language implementations. And the two that are important are the interpreted language family and compiled languages. And interpreted language, at one point in time in the early days of computer, were sort of shunned because the very processing is called on the fly, and it's done by an intermediary software at the program's runtime. And due to that very fact, there were a lot of CPU cycles required in order to actually run the program. And without the horsepower availability in the computer, this often resulted in sluggish performance. There has been so many advances in the computer world, and processing speed has become so much more powerful that interpreted languages have really percolated up much higher in use. Python is probably the most popularized programming language, and it is indeed an interpreted language. Other examples would be PHP and most scripting languages. We're going to do some bash scripting in this course, and you will get a taste for that. Compiled languages, the other category, are those that are translated into a low-level code that is specific to the target computer upon which it will be run. And then at runtime, it's that binary code that is actually running. So it is efficient in its execution. Because the machine specific code is what is run, the execution is quite fast. But that said, once a program is written, it cannot be just readily distributed to everyone to run. You must have a specific compilation for the target computer. And examples of those languages include C, Ada, and Fortran. You still see a lot of C, C++ in the world, but Fortran has sort of diminished into the background. It was once a quite popular language, especially amongst scientists and engineering type programming. Let us turn our attention to our Linux Mint command line. You can see that I am at the command prompt. I am in the bash shell. There happens to be something called an environment variable that I can echo out to my screen that tells me which shell I am running. And it is indeed bash, the most popular of the Linux shells. shells are a key component of any Linux distribution. And shells offer for us some basic features. We can do scripting in the shell, and we will learn to write some scripts in this class. But let me just move to my directory that I've named bin, and you can see I use the cd command to do that. And now I'm going to use ls for a listing of things that are in that bin location. Now you can see that I have, well, quite a plethora of different files in this location. A lot of them are color coded with this nice green color. And in Mint, that color coding represents files that are executable. We can see by using the long listing with -L that these green colored files do have the X or executable feature with them. This one file here, not just one, but we'll just look at this particular one, final.js, is not green colored. And if we look over in the file specifications area, we do not see any X's. So that is not an executable file. Any file that has a dash in this first column is considered to be just a plain Jane old file. Okay. Let's move up one level, and we do that by cd space ... And you can see that I've jumped up one level in my hierarchy. I'm back to, we can see where I am by using present working directory or pwd. I'm back into my user account's home directory, which you can see is not the same place as /home. There's two different locations. So the home directory and your home directory are two different locations. If I do a long listing in this location, I can see first that I have a lot of files here, but I can also see that not all of them begin with just a dash. Some have a D in this first position, and those are directories. There are other types of file descriptors as well, and you did do an exercise early in the semester that talked about some of the others, but the two main ones that are going to be important to us are the dash for a regular file and the D for a directory. So the Linux shell supports scripting. It can be customized. You can see that in this particular shell, we have this nice long command prompt that includes a lot of additional information. In some distributions, you will see merely that lonely $sign with no additional information. Here's another distribution of Linux that I happen to have. And you can see on this distribution that the command prompt is a little bit different than the one that is on mint. Okay, so these different distributions have shells, and those shells can each be customized. Let's look over here on this one, and we'll see we are also running the bash shell, but we have a slightly different look and feel to our command line interface. We learned in our first half of the semester about the MAN system. So let's clear the screen and look at MAN for one of our popular commands, pwd, and make a note of the fact that we have a name section, a synopsis, a description, and then if we move down a little bit further, we see author, reporting bugs, copyright, and see also. And other MAN pages may have slightly different categories, but they almost always have the name, synopsis, and description. And then those follow-on sections may vary, and there may even be a section called examples, which is I'd say a really interesting go-to section of the MAN page, because a lot of times they'll tell you like the most popular ways of using that command. So let's look at a command that maybe we haven't used yet, but we will, called find. And I believe that we may be able to search down through and look at examples, see the examples section for more. So I'm going to skip down through, and here is a section called examples. And you can see spelled out in this section of the MAN page many common uses for the command. So just file that away in your brain so that when we talk about the find command, you can remember to refer to that section. Now, some of the most recent portions of your reading in the Networking Academy content, you were introduced to something called globbing, which is basically a bigger term for wildcards. And typically we use glob or global recognition to as a shortcut. So say I wanted to go back into that bin directory and I wanted to only see files that were the JavaScript. So I might use a wildcarding, the asterisk, to say 0 more or more characters of any form followed by .js. And I would trim down my list from the ls command to only show those certain ones. Say I wanted to find things that started with F and then 0 or more characters, and I don't care what those characters are, and maybe they would be shell scripts. And I do have one that matches that set of attributes, and it came back as factorial.sh. Now, we looked at echo, which just sends something back to the display, and we can echo some environment variable, say the path. We can also echo it as part of a sentence. This is the path on my system, and then have that displayed. But what happens if we run into a condition where we want to use the $ character and not have it be representative as part of a environment variable? So what happens if I say, you owe me $10? Whoa, that doesn't quite look right. It says you owe me 0. That is quite a different message. What is happening here is that the shell, which is the interpreter of the commands that I enter on the command line, is looking at that $ and believing that whatever follows it represents the name of a variable. So it's looking for contents in a variable named 1. So $1 instructs the shell to look for the contents of that variable. We've never defined that, so it contains nothing, and thus we are writing you owe me and then 0. So how can I get to print out to the screen what I intend? I can use the single quote, and this is discussed in the reading material. And when I use the single quotes, that tells the shell, do not interpret in any special way any of the symbols contained therein. So a single quote and a double quote are treated differently by the shell. And the last thing I wanted to talk about is creating files in a, we call quick and dirty manner. And we learned a couple ways to do that. I'm going to go back to my home directory. And if I wanted to create a file in a quick manner named foo, I can say cat space and then issue that greater than sign, right? And give the name of the file. Then I just start typing. This is line 1. This is line 2. This is the end. Okay. And I can hit the enter key. And now I'm going to look down on my keyboard at the control key and the D, and that sends an end of file sequence, and the file is created. Now, if I cat without that greater than sign, the name of the file, here is the contents of the file. Now, say if I wanted to create a file, and I didn't care if there was really even anything in the file. I just need a named file. We can use a command called touch. And I'm going to touch a file named fee. It looks like nothing happened, but let's look at all the files in my home directory that begin with the letter F. And we can see that we have a 0 length file named fee, and we have a 47 character file named foo. So I created a file with some contents, and I was also able to create a file that is named and currently has no contents using the touch command. We can look at the manual page for touch and see that that command changes file timestamps, so we can use it for that purpose, but we can also just purely create a file by that name if the file does not currently exist. A file argument that does not currently exist is created empty. Okay. So there are some useful pieces of information about what we've learned during the first half of our class. We talked about open source and the difference between free and freely. So I would ask you to review those materials, including some of the thoughts and ideology of Richard Stallman, and also just practice the key commands at the command line. Let's look at them again. PWD for present working directory, CD, and you can use either an absolute path. Absolute paths always start from the root and work their way down. So if I wanted to go to home, Deborah M, and the bin directory, that would be an absolute path. And we can look at PWD and see that's where we are. A relative path depends upon where I am right now. So I could actually issue the same relative path statement, and depending on where I am when I do that, I could do it from one location and end up in one place, and I could do it from another location and end up in a completely different ultimate destination. So sometimes I might even get an error. So what happens if I do this and say desktop? That is a relative path. I asked to move up one level and then down to desktop. Now, if I issue that same command again, now from a different location, I'm basically, I went up and back down to exactly the same place. Now, what happens if I go to my home, which I can say the shortcut tilde, and then issue that same relative path? I get an error message, because once I've moved up from my home directory, that means I've moved up from home Deborah M to merely to home. If I look at what is in that location, there now is no desktop directory into which to move. Okay. Now, I could change to this directory Serena and take a look at what's there. That directory is empty, but I could go up one and move then over to the Deborah M. I should get no error message. because that was a valid part of the hierarchy. So PWD, CD, LS, 3 of the most popular commands. Also, if we wanted to cat something that was a long file, we, instead of using cat, we can use something called less, which gives that output to us a screen worth at a time, and hit the space bar to move through the file to the end, hitting Q when we're done. Or we can use a similar tool called more, which does much the same thing, except this time, when I space barred and got to the end, it just gave me back to the command line. Also important command is tail, and we can tail a particular file to find by default the final 10 lines in that file. And head gives me by default the first 10 lines in the file. So if we just want to sort of peek in and see, well, what's going on in a file, those are important commands. So I hope that this has given you a fair review and that much of this information is indeed familiar to you. And I hope that you are very successful when you take the midterm exam.